signal head, and as we can see here we have 3 terminals. We have the main lamp, which is the horizontal lamp, the common, which is the return, and also the auxiliary, which is the vertical lamp. Now the way the bulbs are set, they are preset, just sealed down there and these bolts underneath. So this is set at the focal length for the lens itself, and the main lamp is set at that perfect focal length to give off the perfect beam. When we drop it to the auxiliary, that's just offset slightly, and you can notice the difference out on the track. What we also have is our transformer. Now this is the incoming 110, which comes in on the primary side on the left, goes out on the secondary side on the right. And you'll notice again our main, common, auxiliary terminals, and these go to the lamp. You'll also notice on our lamp we have a small flying lead that we can take on and off, and this is used for testing the filament. It beats taking off the nut on the old school and having to put it back on. Now you've got a nice handy little flying lead that comes on and off. We also have our lamp proving relay, which is current driven. So when our main lamp drops out, this relay will de-energise, make a set of contacts, buzz back at the signal box and warn the signalman that the lamp has gone out. And likewise, when the bulb comes back in, remake the contacts and prove to our signalman that the lamp is lit. Now these are octal relays, and what they do have a tendency to do, I'll just get this one out for you. This is the new one, but if you notice on the bottoms, sometimes you'll get a bit of verdigris in the pins. It has been known in older ones for the pins to actually shear off inside here and create lamp faults. As you can notice, an octal base, nice and clean in there, it's quite new. And again, if you haven't dealt with octal relays before, they have a little stub there that aligns to the stub and hole, so you know which way to go. You can push them back in, and then have a little retaining clip goes over the top to hold it in place. This is our lit filament at the top here, and I'll just show you now. Remember again our filament failure relay and our little flying lead. So as you can see now, not easy to see, but there's our main horizontal filament lit, and I'm just going to drop it to the auxiliary. So it's changed over to the auxiliary, the vertical filament there, and the relay has dropped off as well at the bottom. I'll just tap that on and off a few times for you. You can see the armature moving there. These are our filament failure contacts, so this pumps part of a circuit, so every one of these lamp units, the wire will come in, out, in, out, in, out, and in, out, and off we go back to the signal box. And there may be several signals wired together, so again, once a signaller reports that a lamp's gone out on a signal or a group of signals, it's worth standing in the box for a little while and watching trains go past to work out what lamp it is that's actually gone. Otherwise you've got quite a few signals to check and quite a few lamps to check. So that's a little old trick we used to do. We used to sit in the box with the signalman, just wait for the train to go past and work out which one had gone. Now these are quite new transformers in this ABB signal head, all enclosed, nice, simple. Some of the signal heads you'll find are tucked right in the back. In fact, if you've got an AEI GRS head, like we used to have on the Macclesfield line, these filament relays are twice the size of this, but tucked right in the back and very hard to get off. Though they have got a single bolt just to take them off, and a handle you can actually pull them out with, which is the better idea than this little spring retainer. But that's the difference between old signals and modern signals. One thing you will find problems with, these are the original bulbs, and you can get 8,000 hour bulbs that last a lot longer. You will get burning of the contacts inside. If you look very carefully on the domes, you'll notice the silver in there. That gives away whether it's been underburning or overburning. And also one other thing to notice is you will get pitting of the contacts here. And once you start getting pitting of these contacts, it will affect in there, and it'll start burning those holders down there that you can just see. You'll notice there is a pin arrangement which matches the pin arrangement on this, and we always put it with the 2 pins to the front, push down and twist, and it's in place. That's how you get the bulbs in and out easily enough. So they're held down with a little bit of tension on this tension collar. Again, sometimes these on the old signals, the springs do go. That is a known problem. And again, if the solder burns off this onto those contacts there, it will cause you lots of problems. You'll end up having to change all the contacts. That's another known problem. So that aligns the bulb perfectly, as you can see, our main and our vertical filaments. So what we've done here is we've set our meter up on AC, and we've set it onto our common and our auxiliary. And what I'll do now is take the flying lead off to drop the voltage. So this is the auxiliary voltage, 10.8, and we'll put that back on, and we can get the main voltage. If we put this across to our main, and we should have between 10.5 and 12.1. We tap that back on. 11.9, 12 volts, so that's within our range. As you can see, you can balance this up now on the secondary side. If you balance the incoming side, so on this we'll just change our scale up a little bit. Now our 110 is reasonably 110 coming in, a little bit higher. So if we look, our 110 is 113 volts. So we can balance that around. For instance, we can drop it down to the 98 or the 86, and we can also take 6 off that. We have a 0 as well. So at 113, our closest scale is 110 and 0. So we've matched them to that, which means our outputs should be reasonably matched as well. So our main and our common gives us 13 volts. Now bear in mind, we lose a volt through the lamp relay, because the lamp relay is wired in series with the main filament. When the main filament blows, the lamp relay drops and puts the auxiliary contact in, which is the same as failing the bulb, as we have been doing just there. So we can do that. Now we can also look at our auxiliary voltage. Our auxiliary voltage, 11 volts, feeding out to the auxiliary. Obviously we haven't put that on load yet, so we'll put that on load. Yep, so 11 volts, that's good. And our main, if you appreciate, if we go to our main to the common, whilst that is saying that we have 13 volts there, bear in mind we've actually lost a volt. So I'll leave that on the common. I'll take this off the main. I'll put this actually on the main filament. There you go, 12 volts. So you can see we've lost a volt through that lamp relay just by going from the main back to the supply from the transformer. So that shows all the voltages are correct, 10.5 to 12.1.